to do big things, to do good things, to have a vision. This always drives me in my life. With the LEA technology, we now can contribute to a sustainable global ecosystem as well as to an enhanced telecommunication via space. Big things can only be achieved when you can count on a team which follows you, which believes in the goals, not only at your own company, but also at the partners, at the subcontractors, all the way long, and even during the Corona restrictions. LEA is another proof that the ESA programs and the programs of the European Commission, they can create so much fantastic synergies. The trust of both institutions in us in the LEA team. This boosts us now into the world league. 80 people are working for the LEA companies for all our LEIS projects currently, at all their different positions. But all are fascinated on what they are doing. This is the story, and this makes me happy.
The LEA X5 development marks a significant milestone in the development of a European-sourced large deployable reflector subsystem. Such a subsystem is composed not only of the arm and the reflector, but also of a number of other elements, being it the hold-down and release mechanisms, being it the electronics with the harness to control the system during the deployment, or the thermal insulation to protect the hardware from the harsh environment in space, just to mention a few of them. But all of these elements are brought together by HPS to form a qualified large deployable reflector subsystem, LEA.
I'm involved in the technology development of large deployable structures since the beginning of my professional life. In 2010 I started as a research assistant at the Technical University of Munich, and in 2016 I joined HPS, becoming the lead engineer for large deployable structures, including LEA X5. I'm really proud to be part of the team, having achieved a major milestone with qualifying the LEA X5 subsystem.
Building on the LEA X5 success, I am already working as the project manager for the large deployable reflector subsystem on the follow-on project Simmer. We have a very challenging schedule, with the next milestone being successful preliminary design review already next summer.
TICRA has 50 years of experience in modeling reflector antennas, and our software GRASP is used by all players in the world doing large deployable reflectors. So for us it was a must, but also a great honor to be part of the LEA project and give our expertise to such an important development. So it was our responsibility in the end to tell if the LEA antenna performed as expected. So it was a huge responsibility. I have passion for space and I'm a European citizen. So for me, working with an antenna that could be launched in space has been a dream.
After more than 20 years of extremely reliable software developments for space debris simulations and onboard software developments, Ethermax now proudly contributes to the safety and reliability of LEA in space.
RUAG is a reliable and dependent supplier of deployment systems, and we as a company stand for 100% mission success. With the LEA project, the technical and programmatic foundations were laid. Examples are the way of working, the development of the deployment subsystems or materials and processes. So now we have all the solutions and concepts ready to turn this heritage into flight hardware very quickly and efficiently.
LEA started with an idea, and right now we're developing the real flight hardware, and it's quite exciting for me to be part of this complete development cycle and to be part of this straightforward team. On the other hand, we're part of the Sentinel program. At the end of the day, our hinge has to deploy a 60 kilogram mass at the end of an 8-meter arm. So we are building a system which helps us to better understand what's going on Earth, so to understand climate change.
This project opens up completely new business opportunities, not only for the European space industry, but also for our company von Hörner und Sulger. It's a huge step for Europeans' technological non-dependence. As successfully shown over the last 50 years of our company, von Hörner und Sulger, we use our highly competent and creative team to develop the best solution. The overarching collaboration of several SMEs, bundling their profound expertise, is extraordinary and unique, enabling a new dimension of creativity.
In all HPS Romania activities, we have collaborations with other Romanian entities, companies and institutes, and we are ensuring them access to the European space market. And I have to say that this is an opportunity for all professionals here in Romania, because we have many highly qualified people able to deliver great quality products at competitive prices.
HPS Romania become an important supplier of high precision MGSE assemblies and metallic parts, and managed to provide fully qualified products for various important missions.
And to sum up, we are enthusiastically looking forward to the future and to see our contribution on board future space missions.
Unique from my point of view was multidisciplinary character of LEA project. It was the first time I saw so many different specialists, mechanical, thermal, electrical and RF engineers teaming up and working together. Synchronizing and guiding their work brought us where we are now. Deployment accuracy, repeatability, RF performance, high structural stiffness while keeping the mass low were the major challenges that we had to approach.
For high technology space project, it is of utmost importance to have a stringent product and quality assurance process set up and implemented. These processes need to follow the highest standards as defined by the ECSS and are applied by the European Space Agency for all their space projects.
Since Inês has been committed to European space business for more than 15 years, it represents now more than 10% of our turnover and is an area where we define as a key strategic development area for Inês, also for the country. So in that sense, we also have quite clear that for Portugal it's important to be more present in the space industry. So within this strong and committed team, one special word for HPS Germany, that we've been working with them from 2007, so it's been a long-term partnership and it's been quite profitable for both organizations.
My personal motivation to be part of this project is that it is a life opportunity to be part of of European space history, and I really feel honored and lucky that I am part of such a great team. Large antenna technology is really important. Our world is growing, and with this growth, it is critical that we start monitoring more closely how are we impacting the negative outcomes of this growth. We really need to observe our world.
Years ago, as I started as a PhD student or the student helping at the Institute for Space Constructions in my homeland, Georgia, I was just excited with the space technology and with the kinematics behind. As LEA was starting, the LSS GmbH was an extremely small micro company, and while doing the LEA project and some other research and development projects in the meantime, we are now almost 35 people. Time framing during Corona restriction was really not so easy, but we still managed to go with home offices mixed up with the office work, with the MAIT hall and workshop work, so that at the end it worked.
Whenever we are facing any difficulties or any unexpected issues during these activities I'm more involved in, which are manufacturing, assembly, integration and testing, I try to remind them that this is the first time that Europe is doing and performing a project like this. We can do it always with a smile and working together.
The amount of the parts what we are talking about in our structure is very high. We are talking about a range of several thousands of small parts, and this includes very, very small parts up to larger parts, and all of them contribute to the accuracy of the reflector.
FHP supports this development in order to ensure independence of key technologies and capabilities of European industry in a worldwide competitive market. And with this team, we will have the first step of getting the autonomy of these critical technologies.
My personal motivation is actually my personal contribution to the monitoring of our planet Earth. And I'm sure this project will demonstrate the value of the European space industry. As someone said, progress is impossible without a change. If people cannot change their minds, they will not be able to change anything. And I believe this project, by an innovative approach, will be an unique opportunity and for sure will be part of our legacy for future generations.
The development and especially the manufacturing of high flexible meshes for antenna applications is a very complex and demanding task.
It is made of a very special technical textile, the so-called knitted mesh. This is made of a gold-plated wire that is thinner than a human hair. The gold plating enables a highly electroconductive surface, while the mesh is having an outstanding foldability which is needed to successfully deploy once in orbit.
To face this challenge, the idea behind was to combine the RF and space experience of HPS with the industrial knitting competence of eProjects into one joint venture called HBTEX.
Upper Franconia is a region in Bavaria that's world famous for its textile heritage. At iProtex in Münchberg, we rely on the textile know-how in the region. With our joint venture HPTEX, we now can bring our extensive heritage of high-tech fabrics into the domain of space technology.
In the last years, we have assembled knitting machines, developed special parts and tested new, innovative knitting movements. It's great to see how thousands of gold-plated wires will combine to create a mesh with a length of over 50 meters.
And the requirements are very demanding. We are talking here about the accuracy ranges of several tens of millimeters, which are extremely demanding to achieve. And of course now it became kind of part of me because I have to follow this from the concept up to the end.
While we're doing something that's incredibly difficult, that no one did in Europe, and we're trying to push the technology to a point where no one ever did it.
Joining all this expertise all over Europe gives really a strong feeling that we will be successful all together.
Speaking about the key challenge related to inter-participation on LEA program has been to have ready all the state-of-the-art testing facilities that has been required from a component to subsystem and system level. I'm really confident on the market success of a LDRS design because LEA team that is in charge of that design is composed by 15 companies of 7 different countries and all together covers all the areas of expertise needed from design to test.
So, from my point of view, I think all companies involved in this program are really enthusiastic and the final result will be really fantastic. Also, we have done the final test related to the final unit, the protoflight unit, and trying to get at least the TRL age.